Good day, class. So today I will try to answer all the questions that you have posted on our lecturette video last meeting. So I will try to answer all the questions, and after this, I'll just post my quiz na para dasig. So I have posted our quiz assignment. Your quiz number 2 can now be seen on our Google Classroom. So please check them out. So before that, I will now try to discuss all the questions that you have asked or presented last meeting. So right here, I will now read the questions, or basically your shoutouts. So, sir, good afternoon. Is the total amount of energy or work constant all throughout the movement of the spring? The answer is yes, because we assume that the spring is ideal. Okay? We assume that the spring is ideal, therefore energy is conserved. Okay? Since energy is conserved, so therefore, total amount of energy, your KE and PE will always be equal all throughout. Okay? So, the sum of energy is equal to the work done. Of course, your work done is converted into energy. For example, you apply 2 joules of work to push the spring. So, therefore, 2 joules of work is now in motion. Okay? So, ang 2 joules of work, ina-convert mo siya into movement of the spring. So, energy is converted from potential energy to kinetic energy. Because energy is conserved, so therefore, KE will equals to PE. Because we assume that the spring is ideal. Okay? So, energy is conserved. Kaya nga, kung siya ideal, affected siya by friction. Correct? Friction, heat, air resistance. So, therefore, maapektuhan. So, therefore, we need to assume that it is ng ideal. Just like sa projectile, di ba projectile, may air resistance, gina-neglect ang air resistance. Kaya kung mapektuhan ng air resistance, malain ang trajectories ng iyong mga projectile. What do you mean by neglecting dissipation? Amo siyang bako nga heat. Kaya di ba kung ang imong nga spring, naga-move back and forth, okay? Ang imong nga spring, ga-move sabi, di na ako Nan. Ang imong nga spring, naga-move back and forth, so therefore, may dissipation, correct? Ang spring mo ngayon na mabait na sa mga table, so may friction. So imbes ng energy nga gin-spend yet to spin back and forth, ginimo siya heat. So na-convert to heat. So hindi siya pwede. So dapat we assume that it is neglecting dissipation, neglecting friction, and neglecting air resistance. Okay? So, para ma-visualize. Nan. Muna siya. So, kung may spring kung may spring na may mass on top of a table, kung mag-move ng yung mga spring back and forth, mabungguan niya ng surface, so, na may friction. Okay? So, since may friction, may dissipation. Kaya nga, ma-convert siya into heat. So, imbes nga ang imong nga 2 joules of work will be converted to 2 joules of motion, may part na nga ma-convert heat. So, hindi na siya maging 2 joules. Okay? Nan. Then, napagid, may air resistance nga ga-act against your spring. So, again, ma-convert naman ang imong nga energy into against sa air resistance. Okay? So, dapat, we need to neglect dissipation. So, dapat, amo lang gid na siya. Spring lang gid. So, spring lang gid siya nga nagagiho freely. Without the effects of friction. So, wala friction, wala air resistance. So, 2 joules of work will set this spring into motion. 2 joules man na siya all throughout. Okay? So, sir, good afternoon. If graph is of x versus x for a spring is not ideal, will produce a negative or positive slope. It will still produce a positive slope. Okay? Kaya nga, ang force na gina-apply mo, okay, will affect the displacement of the spring. So, kung dako ang force na gina-apply mo, syempre, dako man ang movement sa imong spring. Correct? Kaya nga, grabe tulod mo. Kung grabe tulod mo, grabe man ang paglupad sa imong spring. Kung dako nga force, dako man nga displacement. Syempre, kung gamay nga force, gamay man nga displacement. Diba that all applies to force equals to mass times acceleration? Kung dako ang imong nga force gina-apply, dako man ang ikagiyos ang imong nga spring. Okay? So since nang spring constant is constant, So therefore, your spring will have a slope sa gyapon. Okay? Now, will it produce a negative slope? Of course, it will produce a negative slope kung gina-compress mo naman ang imong spring. Okay? Kung ang imong naman nga spring nagsugod sa wala na compress, kag ma-apply ka force para mag-compress siya, correct? So ma-compress siya. So therefore, negative na imo nga x. So manaog naman ang imo nga slope. Okay? So force equals to in the negative direction. Negative direction lang siya gapon. So negative direction. So negative slope because on the negative direction. But the spring constant is still the same. Okay? So the bigger the force, the bigger the displacement sa gyapon, but on the negative direction. Now, to put square root in solving the speed, because that is the formula for your kinetic energy, Ke equals to 1/2 mv squared. So to solve for v, di ba, we need to square root everything. So example, we need to solve for v squared equals Ke, correct? So Ke over 1/2 then multiplied by mass. So to solve for this, is square root mo tanan. Okay? So V will become square root of Ke 1/2 your mass. So nga gani nag kx squared. So ang formula sa US 1/2 kx squared. Okay. So di ba ang imo to nga curve kanina arao nang dito yung curve na curve slope. Ari siya. Ano siya? So di ba this part ang imo siya nga force, di ba mo siya nga gina force times displacement. So kung triangle ni siya, ano siya? The force, correct? Force times displacement. So the greater the force, the greater the displacement. So may triangle nga ma-form. And remember, force is Kx according to Hooke's law. So di ba ang area sa triangle is 1/2 base times height. Correct? Amo ng area sa triangle 1/2 base times height. So basically 1/2 multiplied by Kx then by x. So mabilin, ang formula sa inyong potential energy will be 1/2 kx squared. Amo na siya. Because the area here, ang tananing area, it actually refers to the potential energy. Okay? Or the potential energy of your spring with the symbol U sub S. Is there any other example of energy with the same formula as elastic potential energy? Is there any other examples? Ano pagiging example? So for example, I will give you what is the potential energy of a spring if it has a mass of 0.1 kilograms and a displacement of, na example, be 1 meter. Okay? So formula equals to 1/2 kx squared. Amo na siya ang formula sa atong potential energy. Amo lang gina siyang formula, but of course there are other formula for potential energy. Like example, PE equals mgh. Di ba may mamala na? Or ari siyang imo potential energy, pwede mo na siya maging work. Okay? So work equals to 1/2 kx squared because work is an example of energy. So ano siya? So 1/2 0.1, amo na siya ang spring constant. For example, okay, hindi ko yung mass. So, example, bigyan mo na lang niyang yung spring constant. 0.1. Where's the eraser? So, muna siya ba? For example, this one will be your spring constant, 0.1. So, 0.1 times x squared, which is 1 squared. Okay? So 1 squared times 0.1 times 0.1 divided by 2, that will be 0.05 joules. Okay? Ano na siya? Nga as circular energy in springs always equal to 2 joules. Siyempre malain siya. Okay? Depende sa gina-apply mo. So for example, nag-apply ka 3 joules of work to set the spring in motion. So along the way, ang total tanan sang iyang KE kag PE will always be equal to 3 joules. Kung pila ang imo gina-apply nga work, amo man na siya ang total energy nga ginagamit ya because energy is conserved. Okay? Pwede nga hindi siya ideal. Ano to? Yes, the base always X because F, ang base tayo is always X because we are referring to F versus X nga graph. Kaya based na sa force, ang movement sa imong nga spring, ga base sa force na gina-apply. Is it possible that the graph ever is not ideal in nature? Possible sa gapon, but we will not get the same results because my friction, my air resistance, denoted U sub S. So U, amon siya nga ito nga symbol for energy. Okay, S for the spring. Okay, ang U actually ga-refer sa system. Ginagamit siya sa system at ang universal system. Okay, that's why usually ginagamit nila as U. Pero hindi ka mo ma-confuse, pwede man ka mo kagamit sa EPE or elastic potential energy. Ang sub S for the spring. So Hooke's law can be applied to any material. Yes, can be applied as long as it is elastic. So pwede ang imong slingshot. 'Di ba? Slingshot. So, pwede ang imong slingshot, pwede ang imong bow and arrow, kay elastic siya. Okay? Any material, as long as it's elastic. Rubber band, that's elastic. Pwede siya. So, possible of energy in springs, possible if hindi ideal. So, idea, Bastillas, possible nga hindi mag-equal ang imong PE or KE, pwede maging hindi equal if the spring is not ideal. So, kung hindi ideal ang spring, energy will not be conserved. So, therefore, hindi maging equal ang KA kag PL throughout. So, why do we scalar object's mass when we resolve? Because we don't need the object's mass, K, to solve for the potential energy. Because we only base on, di ba? Muna ni potential energy, US 1/2 K X squared. But, remember, to solve for X, to solve for K, that's Newton per meter, we can still base it on the mass. Okay, but generally, wala ga affect ang mass unless required sa ang formula. Okay, di ba Hooke's law? Hooke's law is F equals to negative Kx lang man. Okay? So, when saan o maapektuhan ang mass? Pwede siya maapektuhan ang mass kung ang spring mo is vertical. Okay? Vertically mo nga spring, let's say 1 kilogram. Let's say 1 kilogram ang mass ng imong spring. This is 1 kilogram hanging vertically. Then, wala ka kabalo sang may displacement. Sabi for example, displacement is 1 meter man. Okay? Paano ta ma-solve ang iyang for example, ang iyang ng elastic potential energy given the following, the mass and the displacement. So we go back to our Hooke's law. So F equals to Kx or negative Kx. Now, paano tayo solve ang force? Diba? Paano tayo solve ang force? Remember, weight equals to mass times acceleration due to gravity. And weight is measured in newtons. Force is also measured in newtons. Correct? So this becomes, weight is now 1 kilogram multiplied by acceleration due to gravity, which is 9.8 meters per second squared. Correct? So therefore, it is equivalent to 9.8 newtons. So 9.8 newtons Kx. So we can now solve for K by dividing it by X nga 1. So K is now equal to 9.8 Newton per meter. Okay? Kikabalo na tang ang K is 9.8 ng Newton per meter. We can now solve for the ng elastic potential energy. 1/2 Kx squared. So 1/2 9.8 multiplied by X ng displacement. So 1 squared times 9.8 divided by 2 equals 4.9 joules. So, kinahanglan gyapon ang mass. Depende sa problem. That's why mag-solve, dapat kabalo ka kung ano ang formula ng mga gamiton. Okay, answer ko na ni. Because dissipation, ideal, dapat ang spring. Amo ni siya gyapon. Between the force and spring length, syempre, the greater the force, the greater the displacement. Not the spring length, but the displacement. So, equal, hindi siya mag-equal kay energy is not conserved because some is converted into heat, some is converted into ng friction or air resistance. In real uses when it comes to electricity production, yes, pwede sa ang imong elastic potential energy have real world uses when it comes to electricity production because the materials are elastic in nature. Di kung may galabad na kurente generates heat. Di kung generate heat ang imong kurente, pwede mag-expand ang imong material. So maapektuhan ang iyang elastic potential energy. Okay, because of thermal expansion. So, why does it gain some type of energy? Of course, kay imong di ba, imong spring at rest, so potential. So, kung nag-apply ka work para i-extend mo siya, nag-apply ka work, so this now, pag stretch siya, na-convert na siya into kinetic energy. Okay, dito dissipation, answer ko na ni. Total, answer ko naman ni, kay force conserve. Again, F, change of X. So, force multiplied by the change in displacement. Okay? So, for example, ang mga spring nag-start from 1 meter, then nag-stretch to 2 meter. So, may change ka in displacement. Paano mo na ma-solve? I-minus mo ang final position sa imong initial position. So, change in X will equal 2 meter minus 1 meter. So, 1 meter ang imong change in X. Or abo na siya ang gin-stretch ang imong spring. Okay? So, I think that's all for grade 10 Newton's question. I'll now proceed to Curie's question. So, may the same na question. I will no longer discuss kung the same lang question. Okay? So, once again, I have already uploaded the quiz, new assignment quiz 2. So after watching the video, please answer the quiz anytime. Deadline is 7 p.m. So I will now read the class comments. Is there any big difference when dissipation is present? Yes, may dako ginang diferensya. Kaya ma-convert ang imong energy to heat. It loses kinetic energy kung gagawin siya at rest. So for example, ang spring ta at rest, wala gagiyo, 0, negative x, positive x. So, PE siya danay. So, PE is ng 2 joules. So, pag giyoya, ang PE ni will now be converted into kinetic energy. So, at maximum, it will be 2 joules. Pagbalikin naman, ma-KE naman. Okay? Basta ba siya gagiyo, ma-convert na ang PE into KE. So, positive always, again, pwede negative, depende sa direction. Problem, KE and PE. Equal, okay, ari bala, equal sa gyapon. So, going back to the PowerPoint, ano ito ganiman? Nan, araw. So, all throughout, 2 joules ang aton nga energy nga gingamit. So, it takes 2 joules to set this into motion. Pag-abot sa punta at rest siya. So, ma-0 siya kami siya gagiyo. Okay? So, KE is 0, kaya at rest, PE is 2 joules. Now, pag iuwi naman ng halfway along the way, or nag-extend siya, PE is again 2 joules. Kaya nag-rest mo. Okay? Diriya, 2 joules sa gyapon, kaya nag-rest na siya. So, pag iuwi naman, ang imo naman nga PE will be 2 joules, KE equals to 0. Pag abot sa halfway, the total energy will always be equal to 2 joules. Pag-abot naman sa iyang diri nga part, okay, sa iyang maximum kinetic energy, so K equals to 2 joules, P equals to 2 joules. So kung i-add mo na tanan, it will always be equal to 2 joules. Neglecting dissipation because energy is conserved. Why is the energy conserved at the bottom half of the graph as opposed to the upper half? Di na namin mo, Aryo, the area, damo na siyang area below the curve, okay? So, the area below the curve represents the energy. Hindi pwede nga ari, di kaya wala ka data sa babaw. Okay? Kaya ari din data sa dalom. So, amo na sa dapat ang imong nga basihan below the curve. Bis ka na i-convert mo na siya nga diri naman, no? Amo man si gyapon. Kay 1 half base times height man lang gyapon ang aton nga area sa aton nga triangle. So pareho naman si gyapon. But in general, di tagabutang kay area below the curve or below the slope. Yes, constant. So again, at rest, potential, if moving, kinetic. Okay? Tandaan nyo lang basic grade 9. So let's say this one is at rest. So therefore, I mean, push mo siya using 2 joules of work. So may kinetic energy siya. Pag abot niya sa na-compress siya, at rest siya. So therefore, 2 joules. So pagkatuloy naman at rest naman siya. So 2 joules naman ang mga potential. Kinetic 0 naman kawin nagiyo. Pag panawag along the way, KE and PE equals to 2 joules. Then dire, 2 joules naman. Break naman siya diriyo. Then, ano na siya? P equals to 0. Of course not. Kaya nga, may dissipation na. I-divide the resting force. Yes, constant gapon. That's why ang slope tadiyo. Pang-divide ni Black class, Pang-divide niya na, Ang force sa point 1, ang 24 sa point 2. Kaya the same na nagyapon ng answer. Okay, that's why the slope is linear. Kaya directly proportional. I mean, na equal ang slope. Equal ang slopes, therefore, na spring constant remain constant. Is the kinetic high or low? Why? Okay, going back. Di ba pag-extend ko niyo sa iyang maximum, mapaway ang imo nga spring. So therefore, kinetic energy is converted to potential energy. So KE at maximum is 0. Okay? So balik tayo Ari bala KE at maximum is 0. Okay? Kaya nga, ara sa punta, magdapat sa sasabihin mo yung pinaka-maximum yan niyo, amplitude again. Siyempre, at matres siya, mapaway siya. So therefore, your KE is 0. Say is 0. Your PE is at maximum or kung ano da ang in-apply mo nga force. How did the energy become energy before as well as the potential energy become? Depende kung ano ginuna mo. Let's say your at rest siya. Okay, let's say at rest ang imo nga Siyempre kung at rest ang imo nga it will start with potential energy. Kung gimpagiho mo na siya, ma-convert na siya into kinetic energy. Okay? Depende sa problem. Let's say yung problem nag-state nga gagiho na siya nga daan. So equal na siya po sa iya nga potential energy. Na why not joules per kilogram? If I share that that V equals 2,400 joules, that is V squared. So the V is 4 meters. So velocity equals to the square root of joules per kilogram. Sige, balik ta sa nandire. Mana siya. So dapat kuno, kaya di ba meters per second? Correct? So KE di ba joules? Remember joules is kilogram meters per second squared. Okay, ang joules i-search ta bala class ng joules unit. Joules para makita nyo. Ano yung joules? Unit of energy. Joules. Aras ang joules kaso? Kilogram meter squared per second squared. Okay? So, kilogram meter squared per second squared. So, balik na So, nga meters per second ang aton nga Okay? Siya nga meters per second. So, di ba, para ma-solve ang aton nga velocity, KE, it over 0.5 or 1/2, then your mass. So, V squared, siya, mass nyo nga, kilogram. Correct? So, square root. Muna siya. I-square root na siya. Okay? So, KE, again, that is kilogram meter squared per second squared divided by 0.5 kilogram. So, anong makancel? Madula ang kilogram. Correct? Madula ang aton nga kilogram. So mabilin ang meters squared per second squared. Ti square root pa, square root ni. So magiging meters per second. Okay? Magiging meters per second. Hooke's law apply. Of course, Hooke's law, any elastic object, F equals to kx. The more force you apply, the greater the stretch of the spring or the compression. Is there a different formula for the elastic kinetic energy? So when we say elastic kinetic energy, I think the technical term is always kinetic energy. But yung elastic kinetic energy, amo nung siya po ng ato nga basic formula. Ara kaso, elastic kinetic energy formula. Unless ga-refer ka sa collision. Ara kaso 1/2 mv squared. So 1/2 mv squared lang sa class ang basic formula sa imong nga elastic kinetic energy. But syempre, pwede ka derive other formula from that. Okay? Elastic collision, pwede ka derive sa formula sa kinetic energy. But the basic is always 1/2. Ke is always 1/2 mv squared. Any moving object possesses kinetic energy. Okay? Hindi lang spring. So wala actually term nga kinetic, ang elastic kinetic energy. Kaya nang nagagiyo, amo ning gina-follow nga formula. 1/2 mv squared. Okay? So I think that's all, and I hope that I answered all the questions, and I hope that klaro man ako pag-explain. So without further ado, I want you to answer the quiz number 2. I already posted this one. Okay? Deadline 7 p.m. So you will answer, and then you will upload your solution. So, paano mag-answer? Answeran sa papel, then i-encode ang answer, then i-attach nyo ang inyong nga answer, ay nga solution. Okay? You will attach your solution. Okay? So, thank you very much and see you again next meeting, or see you on August 24. And I hope you learned a lot in today's simulation. Okay, so I hope you're ready for 24. See you, because I prepared lots of activities for you. Okay.